form a well-defined table. So that table is nothing but a computation matrix. It is used to classifying models and proceeding establishing decision. So here we can using the matrices like accuracy. So the formula is true positives, true negatives by total sum of elements we can consider. Same way we can consider the precision, true positives and by divided by the true positive and false positives only. In the recalls also we can consider the true positive and divided by true positive and false negatives. So then after we can identify the based on the precision recall, we can identify the F1 score. So here we can identify here true positives means is the counting of the positive values, true negative means is the counting of the negative values. In the false positive means is the predict positive from the cross table and its values of the false. So it's the one type of errors. We can consider generally the type 1 error. Same way we can false negatives is a type 2 errors. It can count of the predicts and negative from the class tables. So then after we can take in the data. So that data can be taken from the various databases. So that data can be identified. So the data can be measured to, we can apply on the machine learning algorithms. So that will be divided into what are the segments, what are the attributes we are using. So the attributes can be taken, and here we can applying the what are the required things like data cleaning and data analysis here. So then after we can given to the best model. So here we are taken the all the classification models. See here we are not considering any best model. Here we are taking all the classification models. After getting the accuracy based or F1 based, F1 square based or either patient based. So depends upon user threshold, we can identify one of the best classification model. So from the data set, we can take the all the classification models, classification results will be getting from the data sets. So it will be given to all the classification models. So it will be available in the lazy supervised learning lazy predict package. So it will be gives the entire classification models evaluation metrics with time taken. So it will be very useful. So which one will be taken the very less time, which one will be taken very less. Individually we want to calculate the data, it will be taken more time. So suppose here we are produce the 20 around more than 20 classification models are there. So we want to evaluate each and every one, it will be taken more time. But using that package, we can directly within the seconds we can getting the data. So after that we can which one is the better, we are comparing to the model. So in the classification figure 1 we are what are the models we are taken, so that will be comparing and various classification models. Next, so the result will be, so that will be showing you what is the best accuracy. Suppose here we are considering only accuracy, so which one will we give the best accuracy? So it will be taken based on the time, or we are directly taken the accuracy. So as per threshold, as per user threshold. So then after we can represent the one is the classification, which one is the suitable. So based on the user threshold, so we can get in the taken. So finally the conclusion is, so here we can provide the evaluation metrics for all classification models available in the supervised machine learning. So that process will be generally we are taking very lot of time, but here we are using the supervised lazy predictive supervised learning. So it will be avoid the time consuming. So it will be consider the leaf disease parameters, and it will be identify the like take the fungus, virus, and so finally it classifying the best fit model. So it will be very helpful to the identify the disease. Finally the evaluation matrix based, so the user can be identify the so which one is the suitable and which one is the good model to you. So these are the references. So any queries, sir?
Sir, can you explain about your data set, sir? Your data set is raw data or image data? We need
that is my data is the text based data, sir.
So we are how you done the pre-processing, sir? How you applied the pre-processing technique?
So first we can identify the what are the first we can measure various database data will be measured to the one data set, sir. So on that time we are
I'm asking about out of your data sets, so how many are having nothing but it will be classified into two categories, right? So how many of the image of the data is having leaf diseases, non-leaf diseases? So how we categorize the data?
So already existing data, text-based data is available, sir, in the internet. So we can consider the data, and based on that data, we can identify the. So generally, in the extension also, we have the 3 types of categories are available: leaf disease, disease data, non-disease data. So some other one is the uncertain data also available, sir. In further additional research, will be go for the uncertain data, sir.
So the data set you used in this work is pre-processed, sir, already pre-processed data, or you have
No,
done?
sir. No, sir. We are applying the pre-processing techniques.
You what is
Sir.
the technique you applied, sir?
So
To
here we are.
process them?
First, we can identify what are the null values we have. So we can apply identify. So we remove the null and unnecessary data can be removed first, sir. So then after we can identify the any data is not suitable. I mean, not flexible to the data type. So that will be reapply, or we can remove that data, sir.
What are the features are there, sir, in your data?
So here features means we are taken the accuracy and precision recall these
Those
parameters.
are performance metrics, sir. I'm asking about features.
So here here we can take in the like I will show you, sir. Sorry. Just a minute. So here we are applying the bacteria, virus, and fungus. These features are we are taken from the database, sir.
Can you explain about your proposed model, sir? We didn't
So
get any clarity regarding your proposed model. So the way
yes,
you are
sir.
explaining the model is already existing model you are telling. So any novelty thing you have identified, sir, to analyze the leaf disease?
Sir, up to now we are applying the all classification models at a time, sir. It's supervised learning data, sir. So here we have the data that leaf having the disease or not. So that data will be considered. In case we are getting any new kind of data, so that data is uncertain. So that will be converted into certain data. So that based is the novelty is there, sir.
So how you are converting uncertainty to certain, sir? Any techniques you are applying?
So we have so many techniques. Generally, at present, uncertain data is called as the netroscopic logic-based data, sir. So using either game theory models or any statistical models can be applied to, we can identify the uncertainty data into certain data, sir.
Dr. Mohan, sir.
Hello, DILEEP Kumar Garu. Sir, what are the total number of attributes in your data set, sir? At the features?
So here we can take the total 4 features we are considered, sir. One is the bacteria, virus, fungus, and feds.
So these are the 4 features available in that data set, sir?
What, sir?
These are the 4 features only available in that data set?
No, sir. It having many features, but we are considering only these 4, sir.
Okay, sir. Then what is the feature selection criteria, sir? How you selected the features?
So here we are considering the features, which one is the more affected on the leaf. So that basically we can consider. So bacteria is the more affected on the leaf, and fungus also more affected on the leaf. Sometimes the pests also can be damage that leaves. So based on that, we can consider only these few features, sir.
Okay. Then you spoke about some package. Because of that package only, the feed is more like that.
Lazy predict, sir. Lazy predict supervised learning.
Okay. So if the lazy predict supervised learning is already existed and the data set is already existed, then what is the new thing you invented here, sir? What is your proposed model? Because what are the classification models you displayed on that screen? All are existing models only.
Yes, sir.
Okay, then what is your novelty in that work, in this work? What you proposed? That means clearly I'm asking about your proposed model.
So here I am proposing to showing the entire all classification models are showing at the same time. So the based on the user threshold. So here we can providing the time taken also. So what is the time the particular algorithm will be taken this so on so time. In previously, we don't know the time taken, how much time taken for the particular algorithm. Here we can providing the time also. So that's the based on the time or based on the accuracy. So that will be depends upon user can be considered the model, sir. So which one is the best for him. So suppose here SVC model, in case we are considering SVC model, so that will be taken the maximum time 3.56 seconds. Microseconds will be time will be taken. Some models are will be taken the 0.01. So here accuracy is also different. So here we can further here we can showing the what is the time taken for the particular algorithm also.
Okay, great, sir. And you mentioned the leaf disease data. What are the leaves you considered, sir?
What, sir?
Which plant leaves you considered?
Here we are considering the tomato plants, sir.
Only tomato, sir?
Yes, sir.
Okay, okay, sir. Okay, sir. Thank you.
Okay, sir. Thank you, sir. Thank you very much.
Paper ID 190. Paper ID 190. Paper ID 221. Paper ID 213.
Who is available?
Paper ID 103. Paper ID 209. Paper ID 4.
Paper ID 32.
Yes, sir.
Sarvanga madam. Yes, ma'am. Can you please share your screen for your presentation?
Just a second.
Your screen is visible, madam. Please click on full screen mode.
Yeah, I clicked on full screen.
Yes, madam. You are having 10 minutes time. Please go ahead for your presentation.
Okay, so our main base for the paper is comparison of machine learning algorithms to detect stuttering in speech. So, like stuttering is a neurodevelopment disorder in which like the normal speech flow is not fluent. So, our paper was mainly based on detecting stuttering in children, so that early stage detection can lead to proper diagnosis, and they will have to not have to continue the stuttering in their future years also. So this technique used various machine learning algorithms, and we had a comparison between all those techniques, and also the previous work which is already existing based on weighted melt frequency Kepstrel coefficients, and also using deep learning bidirectional long-term short-term memory. So we, and also the previous existing systems mainly focused on English language, not on Indian languages. And this project was mainly done with the guidance from IIIT Hyderabad professors. So they were already doing this project on basis of Indian English data set. So they had like 5 types of disfluencies, like filled pause, prolongation, word repetition, part word repetition, phrase repetition, and all. So this was like frame level automatic disfluency detection system was developed by them. So taking their guidance, we started to do this on our own Telugu data set, because our mother tongue is Telugu, and most children in their early stages are focused on like more fluent in Telugu language. So then the detection of stuttering in speech would be easy in if they spoke in their mother tongue. So we thought of developing the system based on Telugu language. So what we did is, the problem was we didn't have a proper data set of Telugu language to perform the classification techniques. So what we did is we visited various schools, and we collected the voice samples from various children whose voices were clean as well as with stuttered speech as well. So I'll show the sample of the data set. So this is the sample of the data set where we divided the whole speech sample into individual syllables, their start time, end time, and the total duration. And the classes means the labels in the data set, like 0 means clean, 1 means filled pause, 2 means monosyllable repetition, like that, so on up. 7 means blocking, like complete stuttering to clean sample. We divided the whole data set into classes. And on those classes, this is the architecture of the model. So here we input an audio wave file, and the dataset is created. Dataset is created, and we input an audio wave file. So the data is pre-processed. MFCC features are extracted from the data. So these classification algorithms are applied, and the output is generated. So coming to the pre-processing techniques, so methodology is like this. So we input a audio sample which says like this text in Telugu, and so we annotate each syllable into which class it belongs to. So next, MFCC features are extracted. So we load the data set, we perform classification techniques, train and test data is used, and we check the accuracy with we check the performance of the model with the accuracy F1 score. So this is the comparison of results in the table. Like we got highest accuracy for random forest algorithm. So in terms of pre-processing, what I would like to explain is, so we divided the whole voice sample into individual frames. So it happened is like total 39 MFCC coefficients were extracted from the input voice sample, and their frame length was calculated, like the duration. And these MFCC coefficients are taken as the X constraint to the model. And the Y constraint is like where we declare two time stamps, T1 and T2, where T1 is declared to 0 and T2 is the total duration of the input voice sample. So then the 4 parameters were checked, like T1 is less than start time and T2 is less than start time. T1 is greater than or equals to start time and T2 less than or equal to end time. And T1 less than start time, T2 greater than or equal to start time. And T1 is less than end time and T2 is greater than end time. So all these parameters were checked, and these constraints depict all the possible test cases where T1 and T2 could possibly lie between. So these were taken as Y input. So this is the whole audio clip was divided into each number of 52 number of frames. So in each frame we would compare whether it is a stuttered sample or normal sample. So then these two X and Y were inputted into a machine learning model, and classification techniques were done. So from this we got these results. So as we got the highest accuracy from the random forest algorithm, what we did is, using Flask server, we integrated it with the user interface for the proper use by the doctors or any other speech pathologist. So here we had like several options to choose the file from the already existing voice samples, or we had also a record option where user can record and upload the file to test whether the voice clip is stuttered or not. So depending upon the data, it would give the result as whether the uploaded voice clip is stuttered speech or normal speech. So that's it. This is what I want to present about my paper, and thank you so much. These were the references. Hello.
Can you please explain me about your proposed model?
Proposed model. Okay. So what happens is we had all the data samples that were collected, right? So the audio clips were all uploaded, and also they were converted into CSV files according to what I showed here. So each syllable division. So the X coefficients were MFCC coefficients, right? So they were taken from the input audio clip that was given, and
What
the
is
Y
the purpose of that MFCC feature extraction technique?
MFCC features would give the like the filled pause and all those informations, like whether there is any disfluency in the speech or not. It is used in several voice processing techniques, so we used that.
So if my audio file contains noise, how can you eliminate?
Noise, actually we did that pre-processing in the Pratt software, sir. So here this is a software where, like, the initial techniques where we had to divide the data, we uploaded the voice clip in the Praat software. This software has several techniques like marking the regions by syllables and also removing the noise. So this software is very helpful in removing the noise and doing the pre-processing for the voice sample.
Oh, can we use MFCC to remove the noise?
No, sir. MFCC are used to the features which are used to extract from already uploaded noise. So if we put a noisy sample in, to extract the MFCC, it would give a bit not feasible response. Will not get that correct response.
Have you tested your model with noisy data?
I mean, it was like not completely clean, but average noisy data was also working for our model.
No, whenever you are going for paper publication, comparative analysis should be required, right? Not like before pre-processing, what is the results you are getting? After pre-processing, what is the results you are getting? Then only you can say the pre-processing technique advantage, right?
Yes, sir. Yeah.
So you have to run you have to generate the results without pre-processing. With pre-processing, you have to run your model with noisy data. Then only you can have a comparative analysis. These
Okay.
things are mixed in your work.
Okay. Sure, sir. We'll focus on that.
Yeah. Dr. Mohan, sir.
Sorry, sir. Ma'am, you collected the voice data, am I right, as your input?
Yeah. Yes, sir.
So after that, you are going to convert into some pictorial representation.
No, not pictorial representation, sir. We just extracted the MFCC coefficients from that.
Yeah. That
Yeah.
means what is the input for your model?
Input for like the X input would be these MFCC coefficients which are extracted. The Y label would be the classes in which we divided the syllables in, like this part, sir.
So you converted completely into text data, am I right?
Yeah, it's like array data, sir.
.csv file.
Yeah, .csv file is this part, and this is the audio clips were inputted as audio file only. We're using Librosa library.
Okay.
Yeah.
Fine. So go for your results once.
Yeah.
Here you use the random forest, logistic regression, decision tree, naive Bayes only. Why you stick to these four algorithms of these four models only?
So actually, first we when we searched on what models to apply for the process for our process, we thought like random forest was a very helpful, a very high, gave highest results for the classification algorithm. So like it can perform both regression and classification, and also it predicts, and it is easy to prediction and for an easy understanding. So we went to for this models, and also we were suggested by our guide to go with the other two models as well to check for the final check. So that's how we took the.
So you are completely dependent upon the classification, am I right?
Yes, sir.
So if it is completely dependent upon classification, so why you stick for these four only? There are n number of classification models are there, ensembling models are there.
Yeah. Yes, sir.
That means here my question is, what is your new novelty of your work? What you invented new? What is your new proposed model? Because the data set is not created by you.
Dataset was created by us only, sir.
The data set is created by you. Okay, fine.
Yeah.
And
Yeah.
you used these models. Am I right?
Yes, sir.
Okay, then you so by these results, random forest set and the most accuracy. Am I right?
Yeah. Yes, sir.
Okay.
So like in the project, what we did is like the whole data collection thing, data pre-processing, data set creation, and also the X and Y labels creation up to was our part, sir. From that, we just used already existing classification algorithms. And again, we had to implement this in a web user interface also. So that was also done by us. So we didn't get much time to focus on comparing with other classification algorithms also. So this was like our part of our major project. So in the given time constraint, we could only complete till this part. So I think that's where the problem came. So
Okay. Thank you.
Yeah, sure. Thank you, sir.
Okay. Thank you, ma'am. You can leave this meeting.
Thank you so much, sir.
Mr. Dileep, sir. Those who have completed your presentation, you can leave this meeting. Dileep sir. Paper ID 190. Paper ID 221. 213. Paper ID. Paper ID 103.
Sir, I'm ready.
What is your paper ID, madam?
103, sir.
Yes, ma'am. You can start and please share your screen.
Sir, actually, I'm unable to join from laptop. My mic is not working, sir. Can I join from mobile?
Yes, madam. You can join, but your mic and your PPT should be in a proper.
Okay, sir.
Hello, Deepthi, madam.
1 second, sir.
Yes.
Sir, is my screen visible to you?
Your screen is visible, madam, but your PPT not having photos. It is not in a proper
I'll
way.
include photos, sir. I included my name and designation details in this.
But your here photos are missing, ma'am. You have to
I'm the
remove the
only
your
author, sir.
photos.
Only my
Then
photos.
remove those 6 photos and you have to paste your passport size photo.
Okay, sir. Can
Take
I
your
do it?
time, madam. No problem. Take your time. We will give you 10 minutes time. So please
Okay,
come
sir.
and join again with the update PPT. Thank you.
Okay, sir. Thank you.
Dr. Mohan sir, can we call others? Those who are ready.
Yes, sir, we can call.
Okay. Paper ID 6. Paper ID 6. Paper ID 4.
Who is ready with your PPT? Deepthi ma'am,
Sir?
are you ready with your PPT?
Yes, sir.
Okay, what is your paper ID, ma'am?
103, sir.
She has to update
I should
the
include my
PPT.
photo.
Yeah, yeah.
Yes, madam. Take 5 minutes time, madam. Please come back.
Okay, sir.
Apart
Paper ID 190. Madam Nithya, madam. Arokya, madam. I'm verifying the participant list. Arokya, madam. Uma Maheshwari. Madam Uma Maheshwari. Ramya, madam.
Hello.
Hello.
Sir, my paper ID is 213, sir. I'm ready with my paper. Can I start?
Yes, madam. 213 venkata lakshmi, ma'am. Yeah.
As I am Aishwarya, sir. Okay, Venkat Lakshmi is my teammate, sir.
Teammate. Okay. Yes, madam. You can share your presentation.
Okay. Sir.
Please go to presentation mode.
Yes, sir. Can you see my screen?
Your screen is visible, madam. Please click on presentation mode, full screen mode.
Okay, sir. Yes, sir. Is it okay?
No, madam. It is not update.
I have put that in full screen, sir. Actually.
Click on first option from beginning.
Actually, I have put the same before. Now, is it okay, sir?
Not reflected, madam. Can you reshare it again so that updations come?
Okay, sir. Okay, sir. Screen check. Sir, is it updated? Hello?
Click on the first option, madam, from beginning.
Yes, sir. I have clicked it.
Or click F5 on your keyboard.
Please press F5. Madam.
It's not working.
I have actually clicked it, sir, but I think it's not working. Is it still not showing the full screen, sir?
It's still not showing the full screen. Please click on F5 or function button F5.
I have tried all the ways, sir, actually.
Okay,
I have
okay.
already
Continue with your presentation.
Okay, sir. So my presentation is about cancer prediction system using machine learning. So our main objective is that it to detect the cancer and predict the type of cancer at the early stages. So to stop the spread of cancer to other parts of the body. So we have used a machine learning algorithm like KNN, random forest, and decision trees. We have considered 3 cancers: lung cancer, prostate cancer, and breast cancer, which are more frequently occurred. So coming to the introduction, so it's about the cancer, how it spreads, and what percentage of cancer is
Your slides are not moving, madam.
Not moving, sir. So I think it's a problem with the. Sir, is it now okay?
Now okay. Now okay.
Okay. Sir. So coming to the introduction. So it tells about how the cancer cell spreads and how much 45% of patients died due to cancer. So it's better to detect the cancer at the early stages to save many lives. So here's which part of cancer affects on which part of body. Means prostate cancer is a type of cancer which occurs in the prostate gland and so on. Same goes with the lung and breast. So we have also used web technology, which is HTML, CSS, and JavaScript to make the front end. So existing system is that we have researched many papers and came to know that there is no front end technology. in this cancer prediction system. So there is no way for a layman to know about how to predict its cancer and its accuracy. They have performed in literature survey. They have performed a logistic regression, KNN, and decision trees. So we have taken the main algorithms such as KNN, decision trees, and random forest. So here is a problem statement. There is no real-time development. There is no use for a layman to use the system, and he can also not find the risk of cancer using the symptoms at the early stages. So we have proposed this system by creating the web pages, and we have also calculated the accuracy and performance matrices for the algorithm separately for each type of cancer, lung, prostate, and breast. So the interface is very helpful for the common man to know the cancer symptoms and to interact. It also helps to interact with the user. So here are the methodologies we used. So machine learning algorithms like KNN, which assumes similarity between the new data and available cases and put the new case into the category that is most similar to the available categories. KNN is the algorithm we have used for the front end, which is implemented in JavaScript. And next, decision tree and the random forest are implemented in Google Colab using Python. So decision trees we have used as it allows us to fully analyze all the possible consequences of the decision, and then it gives the best outcome out of it. And next, random forest, we have used it so that it can handle large data sets efficiently and provide the highest accuracy. So it can also balance automatically data sets when a class is more infrequent than the other classes. So here's the implementation. First, we have taken the data sets from the Kaggle. So as we have worked on 3 different cancers, we have taken 3 different types of data sets. One is lung cancer, prostate cancer, as well as the breast cancer. So next comes the data cleaning. So based on the data sets, we have taken different features for each type of cancer. So coming to the data cleaning, we have analyzed the data set, and we have removed all the null values and any missing values as well. Next, we have separated how many positive cases and negative cases are there to know what is the frequency of the classes. Next, coming to the pre-processing of the data. So we have to prepare the data which is suitable for the machine learning model. So we have removed all the missing values, as well as we have converted the unusable format to the usable format, which is numbers. So next, we have encoded categorical data into our diagnosis is of positive yes and no. So we have converted them to the digits 1 and 0 to make it possible for the model to make the prediction and to construct the data. Next, we have extracted the input dependent and input independent variables. So next, dataset partition, which we have splitted the dataset into 2 categories, training set and testing set, to enhance the performance of our model. So to find the accuracy also. Next. So in the evaluation after training the dataset, we have used various parameters like F-score, precision, recall to know the performance of our model. Next, here is our block diagram upon which prediction is made. First, we have read the data set. Next, the sampling is done. Next, dividing the next feature selection. We have not used all the features as it have more. We have used chi-square test for the feature selection, and we have reduced the features from 10 to 6. Actually, the data set is of 10 features. We have reduced it to 6. Next, we have used KNN decision tree and random forest. Next, we predicted the output based upon the test data sample and then performance. Here is our results for each type of cancer for KNN decision tree and random forest. We have got accuracy more for random forest. Next, coming to the interfaces, as I told you that we have also developed the front end technology for this, which can be used anywhere. So we have coded in HTML and used CSS for interface attractiveness, and then JavaScript to code the functions. So this is solely for the user to attract, to know more about the cancer. We have also included to check what type of cancers or what to do after knowing the cancer symptoms, what are the risk factors, and so on. So here are the steps we have included. So first, it takes the features from the user using HTML to predict the cancer. So we have included the features like age, gender, family history, and lifestyle factors like smoking, drinking, alcohol consumption, and medical history, previous medical history. So we have used JavaScript to retrieve the user inputs from the form and then send it to the server for processing. On the server side, we have used the machine learning algorithm KNN to build the predictive model. Here for the KNN, we have manually done the code by calculating the distance between the row of each training data and then the test data. So next we have sorted the data based upon the distance values, and then we have choose top k values. We have taken k as 10, so we have taken top 10 values, and then we have assigned the class to the given data based upon the most frequent class of this rows. So we have sent the predicted result back to the HTML place and display it to the user. So we'll be displaying the accuracy as well as the predicted class on the same HTML page itself. So this is the HTML pages that we have. This is the flow diagram. So first it will redirect to the home page. Next, login or sign in. Next, it will direct to the cancer page. We can know the knowledge about the cancer, different types of cancers, their risk factors, their treatment, and so on. So if we click on the predict, it will display you two options, yes or no, if you have taken the test, or no. If you have not taken the test, you have to click on no. After clicking no, let me show you this is the home page, sir. So we have symptoms, treatment effects, and causes. So we have also included the risk factors and when to see a doctor based upon what symptoms. If you have these type of symptoms, you can go to doctor like that. Next, if you click on no, then it will redirect to this page based on the gender, age, and these are the common symptoms of 3 cancers: lung, prostate, and breast. So based upon these common symptoms, it will direct which type of cancer you may have. Next, this is the yes page. So if you have already taken the test, you can select each one of these so that you'll get the options. So here is the lung cancer. We have included 13 symptoms for this, which are we have taken all the features for the lung cancer, like smoking, yellow fingers, anxiety, peak pressure, and so on. So based on this, it will take and then it will redirect to the HTML server and then bring the output. Next, this is the prostate cancer. We have taken only 6 features: radius, perimeter, area, symmetry, compactness, and concave points. Next, breast cancer. So after giving the values by the user, it will get whether the predicted class is negative or positive, and next, accuracy as well. So here is the advantages. This will make us easier in the future to detect the cancer, user friendly, can predict the cancer at early stages, can reduce the cost for the treatment. So conclusion is that we have developed a web application to know the risk of cancer using HTML and JavaScript. and machine learning algorithms. So we have used different type of data sets retrieved from the Kaggle. This will be useful to any user who want to know the probability of cancer, its risk, complications, symptoms, causes, and treatment. So it will be a user-friendly interface, easy to deal and use with. Thank you.
Coming to your presentation, it is like project work presentation, not research work presentation. Research work presentation means it should contains literature survey, comparative analysis. So these things you have to include.
Okay. Actually,
What
it's
are the
a
attributes? What are the features that are available in your data set? Three
radius.
data sets you collected.
Yes, sir.
I didn't get any clarity on why you collected three data sets. What are there? If three data sets are having same features,
No, sir.
then how
Actually,
model can decide what are its ranges with respect to the parameter ranges?
sir, I couldn't understand your question, sir.
So if your, for example, data set 1 contains 10 features.
Okay, sir.
So for 10 features, coming to your classification, there should be a range, right? Which decides whether you are able to get cancer or not.
Yes, sir.
So
We
how
have
you
given
deciding the features?
separate algorithm for different. I mean, different type of cancer, sir. We have given separately. We didn't include them in the one set itself, sir.
Have we merged all the three data sets?
No, sir. We didn't match it.
Okay, then how machine is able to classify different data sets, different features at one time?
We didn't give at one time. Means we have created separate JavaScript page for separate cancer, sir. So differently, we have made it differently. In the same project, we have included 3 different projects, sir. That's it.
Okay, 3 user interfaces for 3 data sets.
Yes, sir.
So what are the we have collected so and so parameters like radius, area,
Perimeter compact.
yes, what are the ranges? I didn't understand. How the machine is able to decide?
Sir,
With
it's
respect to
based on the
range only, right?
yes, sir. It's based on the data set, sir. Usually it's taking how much the lymph size, sir. After taking the test, they'll give the lymph size, right, sir? So based on the lymph size, we have to give the values. It can
What is
range from 0 to 0.5 or 1.
What is the novelty in your work compared to the existing research?
Sir, I couldn't find any actually HTML pages or user interface for this, sir.
User
Just
interface will not come under research work. Okay, first of all, try to understand the research. So user interface, doing a user interface to the model is not a research work. The research work is like you are proposing your in terms of a proposal model, you are providing a solution to the existing works results. And I didn't find any performance evaluation metrics also. So how the machine learning models will able to provide the results. The only thing is you're providing the accuracy or the prediction accuracy. That's it. That's it from my end. Dr. Mohan, sir.
Yes, sir. Ma'am, can you go for the prostate cancer, please? Or the breast cancer, anything not available. Okay, here you found some features like age and radius and area like that. So why you choose these features only?
Sir, it's we have performed the chi-square test, sir. So
okay, depend upon the chi-square test, you choose this one. Okay, great.
yes.
So here you wrote as radius. What is the meaning of radius? Who is going to provide the value?
Sir, after taking the test, they'll provide the value, sir. So
After
based on the
giving
test
the test,
results.
they are going to provide the value.
Yes, sir.
If
It's on the data set.
okay, fine. For every time they have to take the test and they have to provide the value. Am I right?
Yes, sir.
Am I right, ma'am?
Yes, sir.
Okay. After getting all the values, what you are going to be do?
So we'll provide whether they have cancer or not based
Now the
upon
question
the.
set. How we are going to provide?
Sir, we have used KNN algorithm to know whether, based on the features, to
Okay.
know whether
So
the cancer is.
you are developed 3 JavaScript pages for 3 different cancers. You are collecting different data, and you are going to provide the data to same KNN only.
Yes, sir.
The same KNN can classify all the 3 different types of cancers with different types of feature values.
Yes, sir. I have given KNN for each cancer, sir, each type of cancer, sir. Same algorithm. I have just same algorithm, sir.
Okay, ma'am. Right.
Okay, thank you, ma'am. You can leave the meeting.
Okay, sir.
Deepthi, madam, are you ready with your updated PPT?
Yes, sir, I'm ready.
Yes, you can share your screen, please. Your paper ID is 103, right?
Yes, sir. So can you see my PPT?
Oh, yes, please click on presentation mode. It is visible in a
Sir, I'm using mobile phone.
can you change your mode as a landscape instead of portrait? Or can you rotate your mobile automatically? It will convert to landscape mode.
So can you see now?
Yes, ma'am. Can you resize the screen size? Your screen is out of the boundary.
Okay,
So
ma'am. You can continue. You can continue.
Please
okay,
start
sir.
your presentation, madam.
Myself, Deepthi, Dr. Deepthi, working as assistant professor in VIT University, Amravati, and my paper title is Ensemble RoBERTa-BiLSTM Model for Extractive Question Answering Task. So here in web, we can find large amounts of data in full text documents. So with increase in massive data storage from web, it becomes very difficult for the user to retrieve information from large collection, and it's a very complex task as well. So in order to resolve this issue, information retrieval systems were developed, even though we couldn't solve that issue completely because they just provide set of documents as response to the query rather than providing the exact answer. So question answering systems were developed. In this paper, we focus on multilingual question answering systems. So some of the researchers already developed multilingual question answering system using machine learning, deep learning, as well as some of the transformer models are also used. But so we thought of developing a question answering system where it's a hybrid model which combines RoBERTa pre-trained model with BiLSTM in order to produce much more effective results compared to the existing ones. And for our work, we used Chive, which is a Hindi and Tamil question answering data set. It is available in KADALI. So extractive question answering is a process of retrieving sentence or any phrase from the text in order to provide specific answer for a given question. So there are various search engines like Google search or various other chatbots like IBM Watson. They provided great strides as applications of NLP. But even though humans can answer a question very quickly, whereas this machines for a machine it will be very difficult to find out or to analyze the answer. So these machines need to be educated or they need to be trained on massive amounts of data, and from which an intelligent architecture need to be developed to provide efficient information. So, in light of recent developments, machines can now analyze text and it can provide much more effective outcomes compared to the earlier stages. So, by using start and end span, we have created RoBERTa-based question answering framework. So, this start and end span, which are present in the transformer model, they are used to provide the starting, beginning of the answer as well as the end of the answer. So, we'll see that in methodology part. So, in methodology, first step is dataset pre-processing. So initially the given text is converted into lowercase letters and then tokenization is done in order to generate tokens from the given text. After that, stop word removal is performed to remove the unnecessary information, and then stemming and lemmatization are done to generate root form of a word. So here for efficiency, we maintained a maximum sequence length of tokens which is limited to 512 characters, and the input which is provided to the RoBERTa tokenizer is the concatenation of the context as well as the query. So in order to separate both of them, like we are providing both of them together, so there should be a separator. For that we are using SCP token. So between context as well as the question, will be using separator token, which is used to separate both of them. And coming to RoBERTa model, so the architecture of RoBERTa is almost similar to BERT model. Just like BERT, here also there are total 12 encoder blocks of the transformer are used. But the difference is, in BERT, there are few problems like modal degradation. That means even though if we use larger models also like BERT large, it didn't give better results. So if we consider race, which is a reading comprehension data set for examinations, it gave very worst results on BERT large compared to BERT base. So that is a modal degradation problem. And at the same time, number of parameters are more in BERT. So if we consider BERT base, there are total 110 million parameters. Similarly, BERT large also 330 million parameters, like that. So if there are more number of parameters, then training should be more. So if the dataset size is very huge, then it takes more amount of time for training, as well as it consumes lot of resources. Like we need more amount of GPUs and TPUs in order to train the model. So RoBERTa model, it resolved all those issues. At the same time, some of the major differences between BERT and RoBERTa are, here there is no process of next sentence prediction, which is used in BERT model. At the same time, in BERT there is a static masking, whereas here dynamic masking is implemented. That means if there are total 10 epochs, for example, in first epoch few words in the sentence are masked, whereas in the second epoch the words which are masked in the previous phase and the words which are masked in the second epoch, both of them are different. Like that, it will take different set of words for every sentence in different epochs. So because of this, it will produce effective results. So say suppose if we consider words like W1, W2 and so on, Wn, that's a word sequence. So we are going to provide the set of words as input to the encoder. So as I said you earlier, there are total 12 encoder blocks in the transformer. So for the first encoder part, we are going to provide these word sequence. And there is a part called self-attention and feed-forward neural network in every encoder. So the role of self-attention here is it will calculate attention scores for every word with respect to other words. So because of this, it will be easy for a machine to identify how two words are related to each other. Relationship between the words can be identified easily based on the attention scores. Say, suppose I have a sentence like this: elephant is an animal. Then it will give very less scores for is and an. Whereas elephant and animal, if
And
we
your
consider
slides are
both,
not moving, ma'am. Still it is showing robot mode.
I'm in RoBERTa model only, sir. I'm just
You are
explaining.
explaining some example, right?
That example I didn't keep in PPT, sir.
Okay. Okay, madam. Please go ahead. Sorry for that.
For elephant and animal, their attention score will be more. So like that, attention scores will be calculated and they will be passed to the feed forward neural network. So that feed forward neural network will convert the result into a form that can be understood or analyzed by the next encoder present in the transformer. So like this, the output of one encoder will be passed as input to the next encoder. Like that, the process repeats until 12th encoder block. And the output obtained, the final embedding obtained from the 12th encoder block will be from that. So a softmax activation function will be applied on that and will get scores between 0 and 1 for all the words. So by using this start and end token, so here the word which is having the highest score is considered as the start score. Similarly, we'll be using the end token in order to get the end word. So all the words which are present in between, they are considered as part of the answer. So this is how the internal process of RoBERTa works. And so if we consider a question answer pair like this, Q, C, then provide the concatenated representation as input to the model. So just now we discussed about that. And coming to the next layer, so the embeddings which are obtained from the RoBERTa model, they'll be passed as input to the BiLSTM layer through the dropout in the RoBERTa model. So here BiLSTM is used after retrieving the BERT and RoBERTa encodings, and the outputs calculated are then passed as input to the passed as input to the BiLSTM. So after the inputs are encoded, here the BiLSTM layer, it makes use of both the historical as well as the upcoming data. And from which again we are going to generate the final embeddings from the BiLSTM layer, which are used for predicting the right answer for the given question. And then we have the linear layer. So the input sequence is represented like this, a combination or concatenation of query and the context. So answer beginning and ending, both of them, they are represented with the help of token vectors, and the predictions are made based on the time range. So here the hyperparameters used are, so we just use PyTorch in the transformers library, and the maximum sequence length is taken as 384, stride is 128, and then the model is trained for total 10 iterations by considering the learning rate of 2e minus 2. And we used Adam optimizer for training. Then NVIDIA 2x Quadro RTX 8000 GPU RAM is used for implementing our concept. Coming to the results, so we used F1 score measure in order to calculate the efficiency of our model. And these are the attributes present in the data set. So we have context, question, answer text, answer start, and language. So by using Jacob similarity, so we got the answer, right? Actual answer as well as the predicted answer. And at the end, you can see the Jacob similarity obtained. And these are some predicted answers for given questions. So for the ID, these are the predicted outputs. And this is the final scores. So we use total BERT base. So the developed RoBERTa-BiLSTM model is compared with BERT base and RoBERTa base in terms of Jacob similarity and F1 score. And our model gave better results compared to the existing ones. So coming to the conclusion part. So here the multilingual question answering system, it helps the users who are preparing for competitive exams also. Like, so for example, if the exam is something related to either Hindi or Tamil, this data set is especially for that. So they can easily prepare for those exams. And we used a hybrid model where we combined RoBERTa with a BiLSTM layer in order to get much more effective results for the given question. So including this bidirectionality, it helps to derive most precise responses for the question. And these are few references. So I just included only 6, but we considered around 15 to 20 references. As number of slides are restricted to 15, I just included only these. That's it, sir. Thank you. Any questions?
Yes, ma'am. First of all, that was a very good presentation, madam, regarding your research work.
Yes, thank you,
Coming
sir.
to your problem statement, I'm having some doubts. You
Yes, sir.
mentioned
Ask.
about 0 and 1 scores, right?
Yes, sir.
So for that, you have applied an activation function called
Softmax.
softmax.
Yes, sir.
So have you tried with other activation functions? Why? Because 0 and 1 means binary classification, right?
Yes, sir.
To perform binary classification, sigmoid activation function will be the best one. In case
Yes,
of
sir.
multi-class classifications only, you are using, we are able to use a softmax, but I'm having doubt on it. Why, instead of choosing binary classification, why you considered a softmax as an activation function? Have you done any comparative analysis between them, madam, regarding your
Sir,
translation?
actually, in order to when we generate scores for the words, the scores are in between zeros and ones only we got, sir. So I just considered only this activation function for that. Earlier, we used one more, as you said, softmax sigmoid activation function was used for the earlier other works, sir, which is almost somewhat similar to this, but it gave less accurate results compared to softmax. So this time we tried with softmax.
Have you done any comparative analysis, madam?
Sir, as I showed you in this output results, so bird base and
Okay.
RoBERTa base also, so the developed model is compared with the individual models, sir, bird base and RoBERTa. So they are individual models, pre-trained models. They are not giving better results. So we combined both the architectures.
So what is the translation error rate, madam, in your coming to your research work?
Error rate, actually, it's too low, sir, error rate. So I
Those
didn't
results
mention
you should
anything
be,
separate.
you have to include those type of results only also, ma'am. So instead of
Oh,
taking only one performance evaluation metric like F1 score, so
sir.
coming to the machine translation, many popular metrics will be there like BLU score, TER, nothing but translation error rate. So these are the
Yes.
popular performance evaluation metrics to measure the distance between the source language to target language. So
Yes,
instead
sir.
of taking machine learning performance evaluation metrics, so I suggest you have to update your work with respect to the NLP perspective, ma'am.
Yes, sir. Usually for question answering, when we have context and questions are provided, in that case, either will consider either F1 score or one more thing is there, sir. Exact match. So
Yes, madam.
usually we
Along with that,
consider these
whatever
two
you
things.
told is correct. But along with that one, to go for the publication, translation error rate is also required. Then only we can decide whether the quality on the translation is good or poor.
Yes, sir. Next time I'll do that, sir.
Dr. Mohan, sir.
Yes, sir. Hello, ma'am. It's a very nice presentation.
Thank you, sir.
And there is a much novelty in the work. Now I have a question. So you consider the RoBERTa and BiLSTM model, am I right, ma'am?
Yes, sir.
So what is the basis to of these models only?
Sir, actually, RoBERTa is a variant of BERT model. So BERT model is already it became old because most of them they use that. Even RoBERTa also nowadays it became old only as to
Exactly,
say.
exactly. That's why
So
only I'm asking this
so
question.
instead of taking this single one, I thought of combining two so that it becomes something novel.
Okay, okay, great. So now again, you said you combining two. Now again the same question: why you combining these two only? Because n number of models are there for a
Sir,
transmission.
among all the BERT variants, RoBERTa is the best one, sir. It
Yeah,
gave better results. So I took RoBERTa.
I agree with that. RoBERTa is the best model. I agree. So you
So I
combine
took that,
RoBERTa with
sir.
BiLSTM.
Coming to BiLSTM, uh, so I thought of combining with some of the deep learning models
Oh, no, no,
which were already used. So
exactly,
among all the existing ones, BiLSTM is a better one. So even though there are BiGRU and all, so I thought of using
exactly.
this, sir.
But we can't say directly in a research work BiGRO is less accuracy or BiLSTM is a good accuracy. We can't say orally. You have
Yes,
to
sir.
represent it like maybe in a tabular model. Okay.
Yes, sir.
So
Yes,
like
sir.
RoBERTa by GPU, so maybe you get let us say 30% only, but in by LSTM you may get 60%. So you can claim that okay, by RoBERTa and by LSTM combination, I get the good results.
Yes, sir. Actually, I thought of using that in second paper. So
Oh,
we
so
can't use everything. If we use everything in one paper, we'll get only one
very
lesson.
great. And then we are going to check further in the next conference.
Yeah, sure, sir.
Sure.
I'll
And
make those changes. I'll come with a new model.
sure, sure. And the next one is, so what is your input language, ma'am?
Input is it's a data set with Hindi and Tamil samples, sir.
Fine, fine. Suppose if I'm using Hindi, what is the output I am going to get?
You'll get answers in Hindi only.
Hindi to Hindi only.
Yes, sir.
Okay. So how can I get for Hindi to Tamil? Is it
Again,
possible?
this is not machine translation partner, sir. Actually, here this is useful. Like if there are Hindi students, and they can study something from Hindi questions. They'll give Hindi questions. They'll get Hindi answers.
Okay,
So like
definitely.
that.
So is this model is workable for the remaining languages also?
I didn't try, sir.
Okay,
That's what, sir. I'll try in upcoming parts.
ma'am, great, ma'am. You have a good presentation, ma'am.
Thank you, sir.
Great.
Thank you, madam. You can leave the meeting. Thank you.
Okay, sir. Thank you.
Paper ready 221.
Yes, sir.
Can you start your presentation? Please share your screen.
Yes, sir. Can you see my screen, sir?
Yes, madam.
Yes.
Please click on presentation mode.
Yes, sir.
Yes, ma'am.
So, good evening, everyone. My name is Patlannagari Akshara Reddy, and I'm going to be presenting our paper, which is a novel approach in machine learning for solar energy prediction system. And our paper ID is 221. So, yes. Basically, our college uses solar energy in order to meet the electricity purposes for our college. And so we wanted to analyze if our solar energy that is being produced is being used efficiently. And also we wanted to predict the solar energy for the future purposes. So yes, so we predicted the solar energy based on the weather parameters, and there are many solar panels which are present in our college, and we have used data loggers in order to collect the solar parameters, and the weather data we collected was from the website called Visual Crossing, where we have given the input as our college coordinates and collected the weather data. So based on this, based on the parameters from the solar energy dataset and weather dataset, we have created a solar energy prediction system. So our weather dataset consisted of parameters like humidity. I'm sorry, one second. Yes, our weather dataset consisted of parameters like temperature, humidity, dew, solar radiation, precipitation, wind speed, and UV index. And our solar dataset consisted of voltage, current, total power, and many more parameters. There were over 35 parameters. And we have collected the data for over 9 months duration in order to do this project. So firstly, we started with the data pre-processing. Here, the solar parameters we corrected were of like 5-minute intervals. And the weather data set was of 1 hour intervals. So we had to convert the 5-minute interval into 1 hour intervals. And also because of the huge amount of parameters we had, we performed a lot of feature engineering using the correlation matrix and checking if the parameters are correlated. If it's of high correlation, we have removed those parameters. And then came the model selection. In the model selection, we have chosen few regression models. And out of all the regression models, we have chosen the one with the best accuracy. That is XGBoost in this case. And the performance metric we have used is R2 square error. And also the prediction, in the prediction system, we have also included the UI, user interface, where we can input the date of the we can input a future date, and we can get the solar energy that will be generated on that date. Yes, these are all the algorithms we have used and the accuracy we have got. And out of we have used multiple linear regression, decision tree, gradient boost, and XGBoost. Out of them, the XGBoost algorithm has given us the best accuracy of over 81%. And the future scope of this project would be to train the machine learning algorithm dynamically, instead of like giving it a certain data set of a past and then training it. Instead of that, we could include future dates and immediately train the algorithm in order to increase the accuracy. Thank you.
Madam, can you explain about your data set? How many records you are maintaining with respect to this problem statement? How you
Yes.
have done the pre-processing before? How many records are there? After, how many records are there?
Yes, sir. So when we first collected the data, the solar energy data, we have two data sets, sir, solar energy data set and weather data set.
The
Solar
data set is
energy-
purely designed by you, right?
Yes, sir. We collected from the college using the data loggers, sir.
So ultimately, it contains many missing values or some noise will be
Yes,
there.
sir. It
So
had a
how you
lot of.
handle the type of issues?
Yes, sir. Basically on some dates, there were only like we were collecting in 5-minute intervals, no, sir. But on particular dates, there were only two values instead of like number of values in 5-minute intervals. We had only two values, and like there were some outliers, and we have removed the outliers using using some formulas. And then the missing values, in wherever we had missing values, we had calculated the average and filled in the missing values. By the end of it, we did not have many missing values, but outliers were more, and we removed it. And in order to convert it into 1 hour intervals, we used a formula to convert the 5-minute interval to 60-minute time interval, sir.
Can you go to your proposed model?
Proposed.
In your title, you mentioned a novel approach, right? So how can
Yes.
you justify your research work is novel compared to the existing works?
Yes, sir. So in all the existing works that we have seen, most of them included algorithms such as linear regression, neural networks, and some of them included hybrid, but none of them really included XGBoost, or none of them actually had
Not
a
in terms
user
of algorithm.
interface.
It doesn't mean that so and so researcher used XYZ algorithm, so that I am using ABC algorithm. It is not like research is not like. So you have to design your own model, which able to provide the solution to the existing limitations in the real world. So try to tell me the title justification. In your title, you given as novel approach, right?
Yes,
So what is
sir.
the approach you are following? Approach is not a choosing of different algorithms. Okay.
Yes, sir. So the novel approach would be our selection of the parameters, sir. we have combined like a 2-3 algorithms in order to perform the feature engineering, which were correlation matrix using Pearson's coefficient and mutual exclusion. So I would say our novel approach was in the feature engineering part, and also because it was a real-time system and it included a user interface, we called it a novel approach in machine learning, sir.
Dr. Mohan sir.
Sir, ma'am, what is your proposed model? Because all the models what you displayed in the results, once go to the results, ma'am.
Yes, sir.
So here you use multiple linear regression, decision tree, gradient boost, and XGBoost. So everything is existed. Then what is the new thing you invented, or what is the new thing you proposed in this work, ma'am? Because on solar energy prediction, this is not a new one. It is existed before. From last 4 to 5 years, people are doing a huge work on the solar energy.
Yes, sir.
Then what is the new approach you followed here?
Our approach was in the process, sir, in the process of feature engineering and data pre-processing.
Feature engineering.
Feature engineering is selecting the features which are more important.
So how we are going to find the most important features?
Yes, sir. So in the for regression purposes, we need features which are not highly correlated and which are mostly independent. So we drew a correlation matrix and selected the features which are not highly dependent on each other. That is, if they do not have high correlation.
So by using the correlation matrix or Pearson's correlation, this is also not the new things. So everyone can apply. I can also apply on the same data set or on my own data set.
Yes, sir.
Then how can you claim that this is the novel approach of you? If you design a new approach, new feature selection approach, then you can claim. But what you're saying that already existing models only, existing methods only.
Yes, sir.
Okay, good.
Yes, sir.
Okay, you can leave.
Yes, sir. Thank you.
Paper ID 190.
Yes, sir.
Paper ID 209. Dr. V.Sesha sir.
Yes, sir. Just a second.
What is your paper ID, madam? Hello.
209,
Madam, your
sir.
voice is not available.
Sir, can you hear me?
Oh, yes, now we are getting your voice. What is your paper ID?
209, sir.
209. But in the list, it is given as Bhargavi.
Yeah, sir. She is our guide.
Okay, madam. Please share your screen and start the presentation. Madam, please click on full screen mode, nothing but presentation mode. Hello, madam. Are you able to hear our voice? Sarah Fatima.
Yes, sir. 1 second. Sir, can you see it?
Now, please click on F5. Function F5
Yeah,
or
I
F5.
clicked it. Can you see the slides changing?
No. Can you re-upload your PPT again? Reshare your PPT again?
Just a second.
Fatima ma'am, are you there?
Yes, sir.
So why the presentation is stopped? Is there is any technical glitch or what?
No, sir, just a second.
Sure.
Can you see my screen now?
Your screen is visible, madam. Please click on presentation mode.
Now?
Yeah. Please start your presentation. Go to the first
Yes,
slide.
sir.
Go to slide number 1, please.
Yes, sir.
Yes.
Uh,
You can
So
continue.
basically, sir, I'm Sarah Fatima. Now I'm presenting my project. This is basically on dietary assessment report generation using the RCNN model. This model
Madam, you
is
are presenting your
basic.
research work, not project work.
Yeah, yeah, sir.
Okay.
So shall I say what our project basically does?
Please. Okay, please carry on.
Sir, our project is basically based on RCNN, which is trained on 250 images in total, which have 5 categories, and each category have 50 images in it. And based on that categories, our output of our the project will display the calories, proteins, and fats content uh, in that food item. So basically, you have to enter your food item, and it detects whatever the food item it is, and then basically display all the outputs like calories, proteins, and fats. So this is basically based on RCNN project, but we have even researched it that it is food detection using SVM and different models as well. But based on different model, it doesn't gives a lot of accuracy. So RCNN is the one model which gives us the more accuracy, and it also helps in detecting two images in a picture and giving us the output. And our project future scope is that it can be even applied for a video, like breaking down it into frames and so. And
So the future scope for our project majorly involves trying to include more categories of food, as well as trying to let the users know that what particular food will is more suitable for them, or how much they can improve their calories, what else they can include in their food in order to improve their health. So we have used only 5 categories. So our future scope would be to include more categories, and that will need a lot more of a GPU. But the scope, it can be to more than 10 categories or 100 categories or something like that. So this is what we have performed. We have done as a project, and the output, we got it as 99, 95% sometimes. So majorly the output, the accuracy observed is 99%, and the images are getting detected very accurately. And if there are 2 or more images, they are also getting detected. So maximum of 3 or 4 are being able to get detected with our project. So this is what we have done for our project, and we wanted to present this just to make sure that everybody knows
to assess their dietary details, and they can choose the food according to the report that has been generated. Thank you so much for giving us the opportunity to do the presentation. We are really grateful that we could tell about our project to everyone. Thank you so much.
Okay, ma'am. And regarding your research work, I'm having some doubts.
Yes, sir.
So how can you judge why you choose RCNN instead of CNN? Can you have you done any comparative analysis between CNN and RCNN?
Sir, we have chosen RCNN because it's region based. So we have seen in a lot of other research papers that the accuracy that we are obtaining with the RCNN, which is the regional based one, is really high. So that's why we thought, how about we include this algorithm and try the dietary assessment. So that's why we have chosen this over the CNN algorithm.
Yes, madam. Instead of telling orally, have you done any comparative analysis on the data set with respect to the two models, CNN or RCNN? Then only you can prove, right? In terms of publications, you can prove the RCNN is the better than CNN in terms of finding the region.
No, sir. Specifically, we have not tested it upon CNN and RCNN because it would be training the data set separately for both of the algorithms. But in the other papers that we observed, we have seen a research paper on SVM algorithm, which was showing an accuracy of around 75-76%. So we
How
thought,
SVM can work on images directly?
sir,
How SVM can work on images directly?
uh, we are unsure, sir, because we have exclusively worked on RCNN only. Because we have seen that that algorithm was not getting that accuracy.
Can you explain the size of your data set?
Sir, we have chosen 5 categories, so 50 images each in each category, total of 250 images. We have put up 80:20, the test images and the training images.
Any
So,
data augmentations have you applied?
uh,
So with
so
250 images, is it sufficient to maintain the data in terms of training as well as testing?
uh,
Have you increased your data set by using data augmentation techniques?
we chose a very small data set for 5 categories alone because the processing was getting really difficult on the GPU that we were using. Our system was not supporting more, and Google Colab was in supporting a lot. So that's why we have chosen a very small data set. And as I mentioned, 80:20 ratio we have chosen for the
Okay,
training and
choosing
testing.
the data set size is not a matter here. You can increase the size of data set also. Even though if you use Google Colab, you can change the environment from CPU to GPU. That is also possible in Google Colab. So why can't
Okay.
you apply data augmentation techniques to increase the data set? That is my question.
We just felt that the training was taking like a lot of time, and we wanted to just test it on the 5 categories. So that's why we have chosen those categories, and we have done it, sir. We wanted to extend our data set, but again, downloading it from the Google Colab to our system, it was not really supporting a lot of content. That's why we have not done, and we have not trained a lot of categories. That we could say in short.
So you implemented this entire research work through CPU only, right?
Yes, sir. In Google Colab, we trained it and then we downloaded that and then we did the
But in
front
Google
end.
Colab, GPU selection option is there, right? Why can't you try?
Uh,
In Google
yeah.
Colab, there is an option called runtime. If you go to runtime, there is an option called change runtime mode. From CPU, automatically you can choose GPU, right?
Okay.
Instead of having a hardware through Google Colab, it is supportable. That's why I'm asking. So
Okay.
how can you measure the performance of this model with just 250 images? That is the main limitation I'm able to find here.
Okay, sir. We could not do it on a lot of categories, but our future scope would definitely be to do on a lot of categories. We will try out doing those categories with the method that you have mentioned, sir.
What is the last function you are using?
Sir, the activation functions you mean?
No, not activation functions. You are using images, right? So you can use
Yeah.
different types of cross entropies, right? So what are the cross entropies you are using? What type of gradient descent you are using?
Sarah, would you want to answer? I'm quite unsure. Uh, Sir, the exact answer to the solution we're not sure. It's just that we did a pre-trained model and we trained it again and then we did it.
Yes,
So the
even though if
exact
it is a pre-trained model, it is possible to change the all the metrics whenever you are compiling. Whenever you are going for compiling is nothing but training. So whenever you are going for training, depends upon the 5 categories. We can choose different types of cross entropies, like
okay,
binary cross entropy or categorical cross entropies.
okay,
These are the basic things we have to analyze whenever you are going for implementation.
okay, sir. We will.
Dr. Mohan, sir.
Sir, ma'am, why you choose the RCNN only? Because there are a huge number of networks are available, autoencoders, vanilla networks, YOLO version V4, V5, V7, now working on V8s. Mobile nets
Yes,
are there. Apart from all these, why you choose the RCNN only?
so we specifically chose RCNN because we did our small research wherein there were papers which used YOLO and there were papers which used SVM and they were not giving a really high accuracy. And RCNN was
It's
in
a
one
very
of the
basic
papers.
small data set. As you said, your data set size is only 250 images.
Yes,
So
sir.
how can you get the huge accuracy like 99%? Is it highly impossible?
Yes, sir.
We can get these much
We
of
were
accuracy using.
I'm sorry, sir.
We can't get this much of accuracy by using only the 250 images.
Yes, sir, because it might have been because of the category that we have chosen, and the annotations that we made. They might have been pretty good. That's why we got a good
No,
accuracy.
no. So with the simple VGG16 also you can get this type of accuracy. So getting the highest accuracy is not the metric you can claim because your data set size is very small. You have to take a large data set. Otherwise, the model is going for the underfitting.
Okay.
You make it the 99.99 also. What are the data image augmentation techniques you applied? You applied anything?
Sir, it's just that we did the annotations and then fed it to the training data set.
Annotation is different, ma. Image annotation is different. Image augmentation is different.
Okay.
Okay,
Yes, sir.
and don't use the word for SVM models. They are giving the good results or bad results because SVM can't work directly on the images.
Yes, sir.
Okay,
Okay.
so you need to use the augmentation methods, image augmentation methods. And
All
what if the
right.
hyperparameters are in your network? Hello.
Yes, sir. You're audible.
Yeah.
Yes, extension to that question. Have you done any model dot summary? You perform model dot summary code, so you will get the entire pattern of your RCNN architecture, right?
We have not performed that, sir.
So the pattern is also very important. Then only you can identify what are the parameters which are involved. So Aishwarya, what you belong?
Yes,
You're a
sir.
student, right?
Yes, sir. I am a student.
Third year or final year?
I'm the final year student, sir.
Being a student, presenting this type of work is really very good. Why? Because your friends are there, but they are not supporting in question and answers. But anyway, the way you are your standing on our questions is good one. First of all, we have to congratulate you. Being a student, it is very difficult to answer different persons' questions. First of all, yeah, okay. Thank you so much for
Thank you.
attending.
It is really motivating that you told that
Yes,
to me.
try to understand the questions. Why? Because if you include these questions, maybe that can be helpful in your technical rounds also. So
Yes,
whenever
sir.
you are going for interviews, technical questions will be like this only. So
Okay.
telling the problem statement and explaining about the algorithms is not sufficient in this recruitment situation. That's what try to think everything is in a positive way. Okay.
Yes, sir. Absolutely. We will.
Okay. Okay, ma. Thanks for attending. You can leave the meeting.
Okay, sir. Thank you. Thank you so much for having us.
Paper ID 190. Mohan sir, paper ID 190 not yet joined till now.
Okay, there's something special. Someone is there.
No messages I received, sir, regarding this. Paper ID number 4. Paper ID 6.
I think 3 are balanced.
Oh, yes, sir. 3 are out of
Get to them. Let me
out
see.
of 9. 1, 2, 3, 4.
Only 3 are
6.
balanced.
Yes, sir. 6 are completed, sir. Only 3 are pending. So may I know who is this person? Something special.
So I think we have to ask the organizers to call these persons and make them to join immediately.
Let me put one message in a group, sir.
Sure.
Regarding. So I'm removing something special in this meeting, sir. Yes, no.
Okay.
రే నువ్వు ఏంట్రా ఈ మెసేజెస్ రే నవ్వు వచ్చేస్తుందిరా
నేను ఆపుకుంటున్నాను.
నువ్వు ఆపుకుంటావులే నువ్వు
ఎంత పొలైట్ గా పిలుస్తున్నారు. ఒక్క రోజు పిలిచేవరా కాలేజీలో అలాగా? సార్ మోహన్ సార్, డాక్టర్ మోహన్ సార్.
ఓకే ఓకే
We can ask the organizers to call them, sir. Organizer వంశీ గారు కాల్ మీ. నేను ఇంకొకటి కాల్ చేస్తాను. దీంట్లో ఒక విచిత్రం చూసారా?
Sir, please tell me the ID, sir. I'm putting message in the WhatsApp group. Paper ID 190.
ఉన్నాము ఇద్దరమేంట్రా?
చెప్పండి సార్ మళ్ళీ స్క్రోల్ పేపర్ ఐడి 4
190
not
number 4 number 6
this paper ID
number 6 ఏమనుకున్నావు? బ్లోఫిష్.
బ్లోఫిష్.
మన క్వశ్చన్లకి తెలిసి నాకు తెలిసి రాదు నాయన.
రికార్డ్ ఆపేస్తా ఉండకు.
ఓ నీ రికార్డ్ ఉంది ఇంకా.